Alright, in this video we're going to take a look at how to solve some higher level problems. This is worksheet number 2 for solubility in the advanced grade 9 science course. We're looking at page 75 in our booklets, and the worksheet number 2 starts off, the first 3 questions are simply a review of things that we've already done. So I'll do just one question, one part of each of those questions, and then we'll jump into question number 4, which is a little bit different today. So the first question is asking us to calculate the solubility for different salts at different temperatures. And we know that we have a solubility graph that looks like this, the solubility curves, and on the y-axis of the graph is the solubility of different salts in grams per 100 mils of water. On the x-axis is temperature in degrees Celsius, and there's a whole bunch of curves with the names of different chemicals on the side, the formulas of different chemicals on the side. So looking at question 1, we're just going to be reading that graph. What is the solubility of different salts at different temperatures? There's one that's a little tricky. It says NaCl in part C, sodium chloride, in boiling water. Boiling water, you know, is 100 degrees Celsius. Ice water, you know, is 0 degrees Celsius. If you had forgotten that, you can make a note of that now. I'd suggest as we do the review that you don't just watch the video, that you pause it when you're ready and try a question on your own. So I'll do the first one here. What is the solubility of sodium nitrate at 70 degrees Celsius? So question number 1, you're doing this on loosely. So sodium nitrate at 70 degrees Celsius. The solubility is, and let's look at our graph here. Sodium nitrate is NaNO3, and it's this curve here. So we find 70 degrees Celsius on the x-axis. Here we are, 70. We're going to go straight up to that curve, and it happens to be the temperature where those two curves meet. And then we simply go over to the y-axis. So looking at this very carefully, it's just between 130 and 135. And I think it's slightly less than that, so I'm going to say about 134 grams per 100 mils of water. So in other words, 134 grams of sodium nitrate can dissolve in 100 mils of water at 70 degrees Celsius. Question number 2 is also review, so again I'll just do one of the questions there. Maybe I'll do Part D. It's a little bit more challenging. Part D asks us to calculate the volume of water that's needed to dissolve 2.5 kilograms of potassium chloride at 20 degrees Celsius. If you think you know how to do that, then pause the video and try it yourself right now. So we're going to dissolve 2.5 kilograms of KCl at 20 degrees Celsius. How much water do we need to do that? So the first thing that goes in my answer is a statement of the solubility. So at 20 degrees Celsius, the solubility of potassium chloride is, and now I'll go to that chart again. Potassium chloride is this graph over here, KCl, and 20 degrees Celsius, we go right up to that line. It's between 30 and 35, and it's closer to 35, so I'll say it's 34 grams per 100 milliliters. Now we had 2.5 kilograms, 2.5 kilograms of KCl. So 2.5 kilograms of KCl. And we want to know how much water to use to dissolve that. So we're going to use 2 unit multipliers. The first will convert the kilograms to grams. So get rid of kilograms and switch to grams of KCl. The second one will convert from grams of KCl to milliliters of water, which is what we're trying to find. That unit multiplier, grams of a salt and volume of water, that's my solubility. Okay? So the first multiplier, the recipe for grams and kilograms, there's 1,000 grams in 1 kilogram. That's a fact that you just need to know. The second unit multiplier came from our solubility, which said 34 grams of KCl can dissolve in 100 mils of water at 20 degrees Celsius. So now we'll grab a calculator and we'll simply take 2.5 kilograms multiplied by 1,000 to convert to grams, multiply by 100 and divide by 34 equals, and we get this rather large answer. So we get, I'll switch that right away to scientific notation, and I'm going to keep two significant digits in the answer. So 7.35, so 7.4 times 10 to the power of 3, and then the units will be milliliters of water. And then we want to put a little statement with that. So are needed, or is needed, to dissolve 2.5 kilograms of KCl at 20 degrees Celsius. Okay, so there's our answer in scientific notation because it was a little bit of a larger number and we needed to show just two significant digits. Again, looking at the units, the kilograms canceled, the grams canceled, and we were left with milliliters of water, which is what we were trying to find. Question number 3 is a very similar problem, but instead of asking us for a volume of water, now we're being asked for a mass of salt. What mass of salt can be dissolved in the given volume? And why don't we try question number B this time, I suppose. So potassium nitrate, what mass can we dissolve in 350 milliliters of water at 75 degrees Celsius? So again, pause the video and see if you can set up your answer. So this is part B. At 75 degrees Celsius, the solubility of potassium nitrate, KNO3, is, and I'll grab my solubility graph. Potassium nitrate is this curve that drops dramatically, and 75 degrees Celsius, so here we are at 75, we go straight up to that graph. It looks to be just a little bit more than 150, so I'll say about 151 or 152. I'll pick 151 grams per 100 milliliters. Now the question said we've got 350 milliliters of water, which is 3.5 times more than 100 mils. So how many grams can we dissolve? So doing some mental math, I expect 3.5 times the 151 grams. But we're going to set it up with the unit multiplier as we always do. There's 4 basic parts to these answers, right? If we were marking this on a test, I'd want to see the statement of the solubility, that would be half a point. I'd want to see a setup of the unit multiplier with the units, that would be another half a point. I'd want to see the answer with the correct units and significant digits, there's another half a point. And finally, a statement like we included there, and there's the final half point. So that would be 2 marks, half a point for each of those portions. If you cut corners, you're not going to get full points, despite the fact that you might have the right answer. So there's my statement of solubility. Now will come my unit multiplier. We had 350 milliliters of water, and so because the volume here is in milliliters, I'm just going to use 1 multiplier to get rid of the milliliters of water and switch to the grams of KNO3, which is what we're trying to find. Grams is mass, right? So the solubility again was 151 grams for every 100 milliliters of water. So now grabbing the calculator, I'm going to take 350 and multiply by 151 and divide by 100 equals, and we'll keep 3 significant digits in the answer, so 529 grams of potassium nitrate. And then a little statement to go with that, 529, so therefore, that's what 3 little dots like that means, therefore 529 grams of potassium nitrate can dissolve in 350 milliliters of water at 75 degrees Celsius. So those three questions were just a review of things that we'd already done. And again, it's important not just to get the right answer, but to show your work in a neat way like that with those four basic parts to the answer. Now, question 4. This is where things get a little bit different. Question 4 says, Alan has dissolved 25.0 grams of sodium nitrate, NaNO3, in 30.0 mils of water at 80 degrees Celsius. The first part of the question asks, what's the concentration of the solution? We had a formula for concentration and a certain way that we express concentration in this course. So concentration for us was mass of the solute divided by volume of the solvent times 100. So in this case, the solute is the salt, the sodium nitrate. The solvent is the water. So we'll take the mass of the salt was 25.0 grams of sodium nitrate. The volume of the water was 30.0 milliliters of water. And using correct number of significant digits, the concentration will be, multiply by 100, right? So that we're going to express it as per 100 mils. So grabbing a calculator, 25 divided by 30 times 100 is 83.3, 3 significant digits, 83.3 grams per 100 mils of water. So there's our concentration. Part B asks, was the solution saturated? Okay, and show the calculation, explain why the solution was not saturated. Well, to do that, I'm going to use the concentration that we just calculated, and I'm going to use the solubility. So we're dealing with sodium nitrate, which is this curve here, and our temperature again was, let me remind myself, 80 degrees Celsius. I'm going to grab my graph and find 80 degrees Celsius. Here we are. I'm going to go right up to that curve. The solubility of that salt is between 145 and 150, slightly closer to 150, I think. So I'll say about 148. So at 80 degrees Celsius, the solubility of sodium nitrate is 148 grams per 100 milliliters. Now there's 3 possible situations that you'll encounter. In this situation, we're finding that the concentration, 83.3, is less than our solubility. So we have 3 situations. So if the concentration is less than the solubility, what does that mean? Well, it means the solution is not saturated. And I'm just using abbreviations. Solution is not saturated. If it's not saturated, then you can make it saturated in more than one way. The second possibility is that the concentration might be equal to the solubility. So if you've made a solution and you calculate its concentration and you find out it's equal to the solubility, then this is telling us that the solution is saturated, because the solubility is the concentration of a saturated solution. A third possibility, one that's a little counterintuitive, is that the concentration might be greater than the solubility. I say that's counterintuitive because solubility can also be thought of as the maximum concentration. So how can you have a concentration larger than that? Well, it's not easy, and it's not a stable situation when that happens. The solution doesn't want to remain this way, but this is called a supersaturated solution. So we'll say the solution is supersaturated. Supersaturated means you've managed to dissolve more salt than you were supposed to be able to. If you've dissolved more salt, then the solution is likely waiting to simply precipitate the extra salt. And in the meantime, it's sitting there in a supersaturated, unstable situation. In this question, our concentration was 83.3 grams per 100 mils, and our solubility was 148. So of those three situations, the one that applies to us is the first one. The solution is not saturated because the concentration in this case is less than the solubility. All right, let's jump in and try part C. Now part C is going to basically talk about how to make the solution saturated. So the question now says that what mass of sodium nitrate can we still dissolve in the solution? How much more sodium nitrate can we dissolve? Well, take a look at how I'm going to answer this and make sure you understand the logic. Don't just try to memorize it. So the first thing I'm going to note is that we're adding more sodium nitrate, which means we're adding more salt. What does not change in my solution? Well, the answer is the amount of water, the volume of water. So the volume of water does not change. Now, I'm not saying that if you add more salt, the volume of the solution does not change. The solution's volume will definitely increase if you put more salt in. But what I am claiming is that the amount of water, the volume of water in the solution, does not change. And if we remind ourselves at the start of this question, the student used 30.0 milliliters of water to make their solution. The reason I point that out, the reason I think about that, is because I'm going to use a unit multiplier as the first part of my calculation, and I'm going to use that, 30 mils, as the starting point because it's not changing. So I'm going to take my 30.0 milliliters of water, because it's not changing, and I'm going to use the solubility, just like we did in an earlier part of this review. So we'll get rid of the milliliters of water and find grams of sodium nitrate. Now, if you understand what we were doing earlier, you understand what this is. This is the solubility, which was 148 grams for 100 mils of water. So this means I'm calculating how many grams of sodium nitrate could have been dissolved in the 30 mils of water. So let's grab a calculator and evaluate that. 30 times 148 divided by 100, I get 44.4 grams, and let's put a little statement with that. This many grams of sodium nitrate could have been dissolved in the water. But notice that's not how much we actually dissolved. We only dissolved 25 grams, but we could have dissolved 44.4 grams. So now we can easily calculate how much more we can dissolve. If we take the 44.4 grams of sodium nitrate, this is what could have dissolved, and we subtract 25.0 grams of sodium nitrate. Go back and look at the beginning of the question to see where I got that from. This is what was already dissolved. And the difference is going to be how much I can still add. So on my calculator, 44.4 take away 25, 44.4 take away 25, I get 19.4 grams of sodium nitrate can be dissolved to make the solution saturated. Right? It could have dissolved 44.4 grams to make it saturated. We already had 25 grams dissolved, So the difference, 19.4 grams, is what we would need to add now to make it saturated. Part D points out another way to make the solution saturated, one that's less obvious than adding more salt. Part D says, what volume of water could we have evaporated from the original solution to make it saturated? So the original solution we already saw was not saturated. Instead of adding more salt, which would certainly make it saturated, we're going to do the opposite. We're going to remove some of the water. We're going to evaporate some of the water to make it saturated. The question is, how much water can we evaporate? So we're going to evaporate water, and just like we did in the previous question, think about what does not change if you're evaporating the water. Well, if you're evaporating the water, the mass of the sodium nitrate in the solution does not change. Again, I don't mean to say that the mass of the solution is not changing. If you're evaporating water, the solution's mass will be going down. But within that solution is the salt, and the salt's not evaporating, only the water's evaporating. So the mass of salt in the solution is not changing. And if we look back at the beginning of the question, there were 25 grams of salt in the original solution. So again, just like before, the reason we stopped and thought about that is because now I'll take the thing that's not changing, the 25 grams of sodium nitrate, as my starting point in my unit multiplier. I'm going to again use the solubility and see if you can figure out what it is I'm going to actually calculate here. I'm going to get rid of grams of sodium nitrate and replace it with milliliters of water. And again, our solubility was 148 grams for every 100 mils of water. So what exactly is it that I'm finding here? Well, if we multiply 25 times 100, 25 times 100, divide by 148, I get 16.9 milliliters of water were needed to dissolve the salt. But is that how much water we used? If you look back at the beginning of the question, we actually used 30 mils of water. So we used too much water. So now if we take the amount of water, 30 milliliters of water used, and we subtract 16.9 mils of water which was needed, the difference, which is 13.1 milliliters of water, can be evaporated. Since you used too much, the difference is how much you can evaporate. Once you've evaporated that, the solution will be saturated. There's one last part of the question, part E, and it's a third way to result in a saturated solution. This time, instead of adding more salt, instead of evaporating water, we're going to try to cool the solution down. And the question asks, to what temperature can we cool it to make the solution saturated? To answer this question, I'm going to sketch my solubility curve. So there's the graph, solubility versus temperature. And for sodium nitrate, the graph looks like that. Now, a solution, you remember, is saturated if its concentration is equal to the solubility. So when the concentration equals solubility, the solution is saturated. So if we simply remember that our concentration, back from part A of this question, was 83.3, I'll just say 83 grams per 100 mils of water, what I'm going to do on my actual solubility graph is simply find 83, go over to the sodium nitrate curve, and go straight down to the temperature axis, and I'm going to tell you what that temperature is. Okay, so we remember that the student started at 80 degrees Celsius. So now here's my graph. I'll find 83. So here's 80, 85, here's 83. I'm going to go straight over to the sodium nitrate curve, which is about right there, and then straight down to the x-axis, and I'm going to be between 10 and 15 degrees, slightly closer to 15, so I'll say 13 or 14 degrees Celsius. That's what this temperature is here, 13 degrees Celsius. So therefore, cool the solution down to 13 degrees Celsius to make it saturated. Okay, so over at 80 degrees Celsius, which was way over here, 80 degrees Celsius, our solution's concentration was less than the solubility. But as we cool down, the solubility drops. Nothing is happening in our solution at this point. It's simply cooling. And when we hit this point right here, our solubility is now 83, and that's the same as the concentration. So at 13 degrees, the solution becomes saturated. Suppose you cooled it further than that. Suppose you put it in an ice bath and cooled it even lower than 13 degrees. Well, then the solution would have to start precipitating. It couldn't, since the solubility is now less than the concentration, at this point it's supersaturated, it's most likely going to start precipitating salt. So during the cooling, nothing's happening to the solution until it hits this magic 13 degree temperature. At that point it's saturated. Any cooling below that, and we'll see a precipitate form. So there's the third way of finding of making the solution saturated, and this is the kind of way to represent your answer to tell me what the temperature should be. I want to see that sketch of a graph labeled something like I did there, and a statement on the side, cool the solution down to 13 degrees. So there's a multi-step problem involving solubility and saturated solutions, making a solution that wasn't saturated in more than one way. So try questions 5 and 6, which are similar to this. Question number 5 actually has a small error in it. It's missing a temperature. So I'm going to say here, in not just water, we'll say in boiling water, just to give you a temperature for question number 5. So we're making a solution of potassium nitrate in boiling water for that question. All right, so good luck with the remainder of that assignment.